let's solve this integral here. Given an integral in this form, you may want to consider using partial fraction. We have to first decompose this fraction here. So how do we do this? Now we have to write a fraction for each of the factor here. So let's start with the first one. That will be a over x here, the first one, plus this one here, b over x plus 1. Now, notice that x plus 1 is to the power of 2. So this is a repeated linear factor. So I have to write another fraction here, plus c over now x plus 1 all square, like that. Okay, and of course, that's equal to the original fraction, 2x minus 1 over x times x plus 1 all square. Okay, now we have to find out what a, b, and c's are. Okay, so let's do this. So what should we do to do this? The first thing we should do is find the common denominator so we can group all these terms together. And I would say we should make the common denominator to be equal to the denominator in the original fraction here. So to change this one to this, we have to multiply the top and the bottom by x plus 1 all square. So that would be a times x plus 1 square all over x times x plus 1 all square plus b times, that would be b times x plus 1. Now divide by this times x plus 1 will be x plus 1 square. Plus here, this will be c times x divided by x times x plus 1 square. And that is equal to this fraction, right? 2x minus 1 all over x times x plus 1 all square. Now, we can group this together. So we have a times x plus 1 all square plus b times x plus 1 plus c times x all divided by x times x plus 1 all square, and that's equal to this, 2x minus 1 all divided by x times x plus 1 all square. Okay, now, since the denominator on the left side is the same as the denominator on the right side, that means the numerator on the left side equals to the numerator on the right side. So we can write that a times x plus 1 all square plus b times x plus 1 plus cx equals to 2x minus 1. Now, let's expand this. So this will be a times x squared plus 2x plus 1 plus b times x squared plus x plus cx equals to 2x minus 1. Okay, so distribute this, we get ax squared plus 2ax plus a plus bx squared plus bx plus cx equals to 2x minus 1. Now, group the like term together. So this and this are like term, right? Ax squared plus bx squared, ax squared plus bx squared. Anything else? No. Now next will be x term, right? So plus 2ax plus bx plus cx. Now finally plus a, right here, and that's equal to 2x minus 1. Okay, now, okay, let's take out the coefficient here. So we have a plus b times x squared, so this part here, plus here, this one will be ax, will be 2a plus b plus c times x. Okay, that's just a, right? That's equal to 2x minus 1. Okay, now, what do we see here? Now we do see that, right? So this quadratic equation is equivalent to the equation here, right? But on this side, on the right side, there's no x squared. That means this term here, a plus b times x squared, has to be 0. Now, in order for this to be equal to 0, a plus b needs to be equal to 0. So a plus b is equal to 0. Okay, here, so that's the x term here, right? With the coefficient here. And we have an x term here with the coefficient 2. That means this is equal to 2. So we can say that 2a plus b plus c is equal to 2. Now here, this is a, it's a constant. And we have a minus 1 as a constant here. So that means a is equal to minus 1. So a is equal to negative 1. Now, we already calculate what a is. Negative 1. Okay, so now we just have to put this negative 1 into here. So we can calculate b, right? Then once we calculate a and b, we can put into here, right? So we can calculate c. Okay, let's do that. So a is negative 1, so negative 1 plus b is equal to 0. Now, negative 1 plus b is equal to 0. Then b is equal to, add 1 to both sides, b is equal to 1. Okay, now we know both a and b, we can put into here. So 2 times a is negative 1, plus b is 1, plus c equals 2. Now this is negative 2, plus 1, plus c equals to 2. This will be negative 1 plus c equals to 2. Add 1 to both sides, c is equal to 3. Okay, so now we know both. Now we know all a, b, and c, right? Then we can go back to this fraction here, or this equation here, right? And put in a, b, and c. Then we have decomposed the integral into something easier to integrate. Okay, so a is negative 1, right? So we can say that here. Negative 1 over x, right? Plus, what's this? b, right? b is, okay, so b over x plus 1. b is 1. So 1 over x plus 1. Now plus c over x plus 1 all squared. So c is 3. Yeah, 3. So 3 over x plus 1 all squared. Okay, so this is the decomposed form of the original fraction here. The original integral. Okay, so we are integrating this right now. Okay, what's the next step? We can integrate this individually, okay? So that is integral of 1 or negative 1 over x dx plus integral of 1 over x plus 1 dx plus integral of 3 over x plus 1 all squared dx. We can do that. Okay. Look at this here. This is a constant negative 1. We can just pull it out of the integral side. So that is negative integral 1 over x dx plus, okay, same thing, 1 over x plus 1 dx. Now, constant 3, pull it out, plus 3 times integral of 1 over x plus 1 all squared dx. Okay, we do know that, right? This is equal to negative ln of x plus this one is ln of x plus 1. Now plus 3 times, what's this? What's the integral of 1 over x plus 1 to the power of 2? Okay, think about it like that. Let's do here. Integral of 1 over x plus 1 to the power of 2 dx. Now, because the highest degree of power inside the bracket here is just 1, so you can see it as this. Integral of x plus 1 to the power of -2 dx. You can write it like that. Now, you just have to add 1 to the power divided by a new power. That's equal to x plus 1 to the power of -2 plus 1 over -2 plus 1. What is that equal to? X plus 1 to the power of -1 divided by -1. That's the same as 1 or -1 over x plus 1. Okay. Now, let's put it here. Three times -1 over x plus 1. Okay. Plus minus is minus. So we can rewrite this as negative ln of x plus ln of x plus 1 minus minus 3 over x plus 1. Are we done? Yes, we're done. So we can plus c here. Okay, so this is the integral for this. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.